Hello, in this video we'll see an example of compound interest. But what we're gonna see is how to find the time of the investment. So here is the example. Find the time of an investment of 10,000 to grow to 18,000 at an annual rate of 6%. If the interest is compounded, first we want to see if it's compounded quarterly. So first of all, what formula we use if the interest is compounded quarterly? So the formula would be AT, the amount at certain time, is the principal, P, multiplied by 1 plus the rate, R, over N. N is the number of time this investment is compounded, and to the power of N times T. So compounded quarterly, meaning that every quarter of a year, which is 3 months, they will calculate the interest, and that interest will be added to the principal, and you become a new principal, and then they wait another 3 months to give you the interest on interest, and the principal. So for every 3 months they calculate the interest, add it to the principal, and do it again. So for the amount here we have the amount is given as 10,000. So basically the principal is 10,000. So this is the principal, and we want to know when the amount reaches 18,000, when would that happen? And the rate we have is 6%. So we have the amount of 18,000 is equal, the principal is 10,000, times 1 plus the rate. 6% is the same as 0.06 over N, and quarterly, meaning how many times in a year? 4 times. So 4 to the power, or 4 times T. We don't know what's T. That's what we're looking for, and this is a matter of solving exponential equations. So what we do first is I'm going to divide both sides with 10,000, and so we get basically 18 over 10, or 1.8. So let me just use 1.8, it's easier. So 1.8 is equal to, so here instead of 1 I'm gonna say 4 over 4. So 4 over 4 plus 0.606 over 4 is the same as 4.06 over 4. We just add in 1 plus 0.06 over 4. Again, 1, I could make it 4 over 4, and that is 4.06 over 4 to the power of 4t. Now to solve this equation, an exponential equation, what we're looking for is the time t. So what I will do, since I have exponent, the variable is at the exponent, either we're going to use natural log or a log base 10. So I'm going to use ln. So ln 1.8 is the same as is equal to ln 4.06 over 4 to the power of 4t. So now the properties of logarithm become handy. So I'm gonna take this 4t and then bring it up front. We're using the third law of logarithms, equal 4t ln 4.06 over 4. So I'm gonna continue in here. So what we're looking for is t. We need to solve for t. So in this case, t equal ln 1.8 divided by, so we divide by both wherever we have here, 4, and then times ln 4.06 over 4. So as you see here, I put the parentheses, now needed, but it's needed when you do calculation in the calculator. And plug in everything in the calculator, you get t equal 9.87 years. So if we have the interest compounded quarterly, continuously, that means we are gonna use a different formula, which we've seen an example before. AT is equal P E RT, which is PERT. Continuously, that means every instance you get interest on interest. So again, the same thing, the same amount. We have 18,000 and 10,000. E to the 0.06 and then times t. We're looking for t. Here I'm highlighting the unknown. And so we have 1.8 e to the power 0.06 t. Since we have e, it's better using ln because they are inverses of each other. So ln 1.8 is equal to ln e 0.06 t. So ln and e inverses of each other, we end up by 0.06 t equal ln 1.8. Solving for t, we get ln 1.8 divided by 0.06. An approximation would be, using a calculator, is 9.78 years. I hope this example is clear.